Okay, chemistry, this is a lesson called Building the Atom, and it's going to teach you how to read the periodic table. The atomic mass of each proton and neutron is one atomic mass unit. In other words, that's simply the definition of an atomic mass unit. It's the mass of a proton or a neutron. We say that they have the same mass. An element's rounded atomic mass number tells us how many total protons and neutrons one atom of its most common isotope has. And we'll get into that in more detail later. So one proton is one atomic mass unit, and one neutron is one atomic mass unit. An AMU, atomic mass unit, gives scientists a unit of measure for mass on the atomic scale. However, it is not practical for lab calculations. So if you look at your periodic table, this is what you're going to see. You're going to see these four entries. The atomic number, this is the number of protons that an element has. It is the number of protons that gives an element its identity. The atomic number is also the number of electrons that an element has in its electrically neutral state. That is, same number of protons as electrons. Electrically neutral means that the number of protons and electrons are the same. Atomic number is also called Z number. The atomic symbol, this is the abbreviation for the element that is used in chemical equations. Atomic symbols are often based on Greek or Latin names, so the letters don't always seem to match the element name. Atomic name, this is the name of the element. Atomic names can vary by language, however, atomic symbols are universal across languages. The atomic mass is the average of the masses of all isotopes of an element, and you'll learn how to compute that. The atomic mass is the average mass of all isotopes of an element. This accounts for the decimal number value. Example, if 50% of the isotopes of an element have a mass of 3 and 50% have a mass of 4, then the atomic mass of that element would be the average of those two, which is 3.5. Okay, the rows in the periodic table are called periods. Rows go across. The columns, those go up and down, are called groups. Each period represents a new orbital. So the first row represents the first orbital, the second row represents the second orbital, third row third orbital, and so on. Each group represents an additional valence electron, that is an electron in the outer orbital. So the valence electrons, so the first column, the one starting with hydrogen going down, those all have one electron in their valence orbital. So hydrogen has one electron in its first orbital. Lithium has one electron in its second orbital, that's its valence orbital. Sodium, which is Na, has one electron in its third orbital, and so forth. If you go to the second column, they have 2 electrons in their valence orbital. So Be, beryllium, has 2 electrons in its second orbital. Mg, magnesium, has 2 electrons in its third orbital, and so on. And we go all the way across over here to boron on down. They have 3 electrons in their valence orbital. 4 electrons, the column have starting with carbon, C. 5, 6, 7, and 8. The transition metals, which is that valley in the middle, have no valence electrons. The ones that do are called the main group or representative elements. Okay, so we're going to learn how to read the periodic table to build an atom. So we're going to take silicon as our example. Now I've taken the periodic table and I've squeezed it together. I've taken out the middle elements, the transition metals, and so it goes straight across from left to right. There's 8 representative elements as you go from left to right across the periodic table. Alright, so here's what you do. You look at, this is the entry you will see for silicon. Okay, and I've created something I call the scoreboard, where we're going to keep a count of how many protons, electrons, neutrons, how many orbitals, and how many electrons in the valence outer orbital. Now the rectangle you see in the lower part of the screen, this is where we're going to draw the diagram. So that's the nucleus. It has protons, it has neutrons. Silicon has an atomic number of 14, so it has 14 protons and 14 electrons. So we're going to go ahead and we're going to fill in our scoreboard of 14 protons and 14 electrons. We can also fill in our nucleus that it has 14 protons. Okay, and we're going to put the electrons off to the side for right now. We're going to place them at the end. Next, now we round the atomic mass to the nearest whole number. This is the mass of the most common isotope of silicon, Si-28. We're going to learn the relationship between atomic mass and mass number coming up shortly. But we're just going to take the mass number of the most common isotope, which would be silicon-28. So that number right there, we'll round it and make it a 28. Now we're going to compute how many neutrons we have. Now we can calculate the number of neutrons by subtracting the atomic number from the mass number. So the mass number is telling us how many total protons and neutrons right there. Mass number, protons and neutrons is 28. We know that the atomic number is the number of protons. And that's a number we already know is 14, so we're going to subtract that. And if we subtract that, we get the number of neutrons, and that's going to equal 14. So we can further fill in our scoreboard, and we can also fill in our nucleus. Okay, so now we've got the nucleus taken care of. Because silicon is in the third period, that is the third row, it has 3 orbitals. So everything in that row that you see covered in green has 3 orbitals. So we're going to go ahead and fill in the scoreboard with 3 orbitals, and now we're going to draw the orbitals. There's 1, there's 2, and there's 3. Okay? Okay, now we place the electrons. The first orbital gets 2 electrons. That's because there's 2 elements in the first row, so it can only hold 2 electrons. That's how you know how many electrons that orbital can hold. The second orbital gets 8 electrons, then it's full. The final 4 electrons go in the outer orbital, and they are spread out. So let's take a look at this. Okay, so there's the first electron. It's going to go in the first orbital. And the second electron also goes in the first orbital. Now the first orbital is filled. There's no more vacancy. Again, how do you know it takes 2? Because in the first row, hydrogen and helium, there's 2 elements. That tells you how many electrons that orbital can take. Because remember, the first row represents the first orbital. Okay, now we're going to go to the second orbital. Now watch how I place these, all right? It's important that you place these the way that I do. It's not important that you start at the bottom, but I want you to, just so that we're all doing it the same way. I'm going to put the first one at the bottom. Then I'm going to start to spread them out. Just like when people go into a movie theater, they don't all sit right next to each other until the theater becomes crowded. Then they start to sit closer to each other. So there's 4. Now the 5th one has to pair up. There's the 5th one. There's the 6th one. There's the 7th one. And there is the 8th one. Okay, so now the second orbital is full. It has no vacancy, okay? So the final 4 electrons go, we set them up the same way as the second. First one goes there, second one there, third one goes up there, fourth one goes there, okay? And that takes care of how you draw a silicon atom. And so now we can fill in that we know that silicon has 4 valence electrons because it is the 4th element in its row. So watch this. 1, 2, 3, 4. Sometimes that's the only thing you want to know about the atom is its valence electrons, because they're the ones that do the chemical bonding. Okay, so now we can finally fill in our scoreboard right there, and there's 4 valence electrons. And that's it for silicon. That's how you diagram an atom. All right, that takes care of this lesson on building an atom.